All right, everybody, let's go ahead and get started. Good morning, good afternoon, good evening. Welcome to the CA IDMS Database Maintenance webcast. This is the second in our several-week series upcoming of educational webcasts hosted by myself, Len Thompson, and Dick Weiland. Before I hand you off to Dick, just a quick reminder, if you are listening to this via the audio broadcast, and I think most of you are, please use the Q&A box right in the WebEx to ask any questions you might have. Feel free to use it throughout the session. But we will be holding all the questions till the end, and we'll get through as many as we can, and we'll capture them for any that we don't get to. We'll follow up with you separately. If you don't see the Q&A box in the lower right of your screen right now, just go ahead and along the bottom of your screen you should see a bunch of circled icons. If you don't see the question mark icon there, actually if you do see it, click it. If you don't see it, there should be an icon with 3 dots on it, which gives you more icons available. Click on that, click the question mark icon, and it'll open up for you. And with that, I'm going to hand you off to Dick, so take it away, Dick.
Thanks, Len. Good day, everybody. If you'll bear with me for just a moment as I adjust the slides to today's starting point. Today we're going to pick up on the very common database maintenance task of enlarging the database. So we're going to be talking about the various, some of the reasons you may want to do that, of course, which we kind of touched on last week. But we'll be looking at the various utilities that can be used for the purposes of enlarging the database. Now, the first thing, when you're enlarging the database, of course, what you're doing that for is you're running out of space for some reason. More data than has been anticipated is usually the general problem. In some cases, it may be that you find indexes are quickly becoming less than ideal in their performance characteristics, and maybe you need more space for those index areas to perform at their top level. So when you're dealing with the enlarging of the database, we like to talk about 2 types of database expansion or enlargement. And really, when you're going to use these various things are going to depend on the time frame that you're hit with this requirement. Hopefully, you're being proactive and you've been looking at some of the reports that we talked about last week, and you're seeing the space utilization growing possibly past 70% utilization, or some other characteristics, maybe overflows are catching up with you, and you're planning some expansion of that database within a future time frame. But unfortunately, many times you get that phone call in the middle of the night that says, we got a 1211 running such and such an application, and that 11 says that you ran out of space. So and all of a sudden now you've got a production environment that is waiting for a larger database, and you've got to get something done right now. So there are 2 groups or groupings of the enlarging process. And the first one is the quicker processing. Those provide short-term benefits, and we're going to look at those as the expand page utility and the extend space procedure. We'll be looking at some of the trade-offs in just a second. The longer processing, but providing longer-term benefits, would be involving the unload reload utility or the reorg utility. Now, the short-term solutions, they are very quick running and are probably going to be the ones that you're going to do at 2 o'clock in the morning when you get that call from the data center saying the job failed because it ran out of space. However, the short-term solutions don't really take into consideration the performance characteristics of the database. They're designed to get more space into that database as quick as possible so that you can continue on with your processing. So some of the things that the short-term solutions do not provide for you. Minimizing overflow conditions, both for calc and VIA records. both the expand page and the extend space do nothing in terms of overflow chains. So if you've got excessive overflow chains in the database now, when you do the expand page or the extend space, you will have the same length chains within that particular database. As a matter of fact, running with that database after you've performed one of these short-term or quick procedures can actually result in even longer overflow chains, which can ultimately result in more I/O to the application. If the database has relocated records in a non-SQL database are created as a result of you having run a restructure against the database. SQL databases, if you modify the characteristics of a table and add columns to that table, you might get some of these during regular processing because of the way we expand SQL records. So if you have relocated records on the database, the quick processes will not get rid of those. So you will still be dealing with some additional I/O when you deal with the relocated records. Minimizing fragmentation for variable length records. Variable length records, as they expand, may not have enough space on a page to expand. So what happens is we create another piece of that record, and we link it off of the root portion of the record onto another page on the database. The fragmentation chains are not reduced in any way during expand page or extend space. And certainly the characteristics of your indexes. If you have too many levels or a lot of orphans or what have you, those conditions still exist within the database. So if you're going to be looking at doing one of the quick procedures, you should at some point in time be considering doing the long-term solutions, the unload reloads or the reorgs, within a relatively short period of time. So look at the quick solutions as something that you will do under the gun in the middle of the night, but then follow up with the longer-term solutions, which will take care of all of the conditions that we just talked about under the short-term solutions. So the first utility we want to talk about in terms of expanding the space of a database is the expand page utility. Expand page is a utility statement. It runs under the scope of, or under the control of IDMS BCF, and it runs in a local mode. Your input parameters come in through the sysipt file, and it produces an output listing to syslist. As the input, it takes the existing database and just reads that database, and then writes information out to an expanded database. Now, we're going to look at a diagram in a little bit talking about this first bullet, but basically what happens is we take the data from an old page and we place it onto an expanded or larger page within the new file. So what you're really doing here is you're creating larger pages within the database. You do not use expand page on a database that are in update mode. I mean, this is something that we've talked about on a couple different things. The cleanup utilities, we're going to be harping on that point with just about all of our utilities, especially those if they're going to be running in a local mode. But the expand page always must run in a local mode environment, so you can't have any updating going on with the database. Theoretically, you could still have that database in retrieval, the old database in retrieval mode, if you have the necessity for people to at least access it, but you cannot have another copy of IDMS and update against this database other than the expand page. Within IDMS areas, there are particular pages that exist called space management pages, and they aid us in finding space on a database when we have to overflow a record. The number of pages and which pages are selected as space management pages are determined based on the actual page size. And when you're going to go through and use expand page, you're changing that page size. So this could end up changing or having an effect on the number of space management pages in the database and which of those pages IDMS would recognize as a space management page. So if you're going to do an expand page, there is a space management clause on there that says page size or space management based on a number of bytes. That's SMI clause, and the physical area statement must be specified to indicate the original page size. If you do multiple expand pages, let's say that this month I came through, I got my 1211 in the middle of the night, and I did an expand page. Next month, the same thing hits me, and I've got to do another expand page. That SMI clause must always have the original page size of the area when the database was originally created. That way, we'll be able to know which of the pages are SMI pages or space management pages and keep track of them and manipulate them properly. If an area spans multiple files, a separate expand page job must be executed for each file. That means that expand page works on a file level, not on an area level. So if I have 3 areas or 3 files making up that area, I've got to do 3 expand pages, 1 for each of the files. And expand page runs with the old DMCL load module. So its major focus in terms of going through the DBMS is going through and accessing the old database. So it's going to need to use the old DMCL load module. Now, here we have just a little diagram of what expand page does. Focus on the numbers, the relative spacing or size of the different boxes is not really proportional to the numbers that we're talking about. But on the left-hand side, we're starting with a page size of 3,032. And we've got, let's say, 4 records on that particular page. And as a result, I've got 500 bytes of free space. Now, the way IDMS keeps track of or handles free space on a page is that we put the data at the top of the page, and at the bottom of the page there are things that are known as line indexes, and they aid the database management system in locating the records on a page. So the data is at the top of the page, the line indexes are at the bottom, and all of the free space that is available on that page is in the middle of the page. So here we're looking at a page and we're saying we've got 500 bytes of space. So from the end of record 4 down to the first line index 4 at the bottom is 500 free space, or 500 bytes of free space. So now we want to go through and expand this particular page, and we're going to increase the page size to 6,032. So what IDMS expand page, or the expand page utility, will do is we'll take the data, the header and the data from the old page and move it to the top of the new page. It will then go down to the bottom of the page, take the line indexes from the old page and move those to the bottom of the page in the new file. So now we're adding 3,000 bytes. What in essence we've done is we've increased the amount of that free space in the middle of the page to 3,500 bytes. So it's just a very simple procedure of taking a chunk of data from one page and putting it at the top and another chunk at the bottom and keeping that free space in the middle of the page. So our steps for doing an expand page, first of all, we want to allocate our new database files with the new block size. It is not necessary to format these particular new files because expand page is going to move the data and build initialize the remainder of the page as is appropriate. So the areas that are going to be expanded, we want to make them unavailable to update in a CV or, again, in any other local copy of IDMS. So we can only have one copy of IDMS running update against an area, and in this particular case, that's going to be the expand page utility. So the area has got to be only in use for update processing by expand page. Here we can back up the original file or simply retain the original files as your backup. So we may have an automatic, backup file created just by saving the old copy of the database, because once we've done the expand page, there's no longer any need for IDMS to go back to it. So it could become your backup. You would run the IDMS BCF utility with the expand page statement. And the expand page statement will specify the new page range, and it will use the old DMCL. So after the expand page process is run, we want to go into the segment definition for that particular area and update it to reflect the new page size and place in the original page size within the SMI clause. You'll then generate, punch, and link the DMCL that contains any of the DMCLs that contain that segmentation, or that segment definition, I'm sorry, and then finally back up the new database area. You want to make sure you've got that backup copy after you do the expand page, because let's say something happens later that day, you don't want to have to go back and redo the expand page. It'd be nice to be able to just take a backup and restore that expanded database area. Now, our other short-term option is the extend space. Extend space is not actually a utility. It's a procedure. So there is no specific program or utility or command that you're going to execute. It's just a series of steps that you're going to perform. Basically, what we're going to be doing here is adding pages to the end of an existing area. So if I've got a page range of 1001 through 2000 and that area has filled up, what I want to do is add pages 2001 through whatever is necessary. Let's say another 500 pages. So that would be pages 2001 through 2500. That space within the database is really more or less used for overflow types of processing. We're going to be getting into that in just a little bit here. But basically all we're doing is keeping the original information in the first 1,000 pages with the example I gave you, and then allowing the information to more or less, or new data to more or less overflow into the new pages. Now, to be able to do an extend space, you have to have free spaces available at the end of an area's page range. So if I have a page range defined of 1001 through 2000, but that DMCL has another area that is using pages 2001 through, say, 3000, we are not able to do an extend space with that area because we don't have pages that we can specify or add to that area. They're already used by this other area that might be totally unrelated to the database area having the problem. If those pages do not exist, you can possibly a couple different things. Certainly, you could do an unload, reload, or a reorg and change the page range completely. But again, those are your longer-term processes that can take maybe more time that you have in the middle of the night. But there's another utility called a convert page utility, which we will be looking at the end of this particular session in a little bit more detail. And what it does is it changes the page numbers and all the associated DB keys of a particular area. So I could conceivably run convert page to take my target area and put it to another page range where I am going to have an additional 500 pages past the original allocation, or I could take that other area that was involved, that was blocking my extend space, and do the convert page on that area and move it to a different page range, and then I can use that page, that extra 500 pages that the other area had been using. So again, we'll talk about convert page a little bit later on within this section. So as I point out, the pages added to the end of the area are used to store record occurrences that are overflowed from a target page range. So when we're going through and we're going to store a record, IDMS comes up and determines a target page. A calc record is going to go through and determine that based on hashing the calc key of the record, and one of the factors in the hashing algorithm is the number of pages in the area. So when you do an extend space, we do not change the number of pages for the purposes of calc key hashing. So all calc records are still going to target into the original page range. Now, if there is insufficient space for that calc record to be stored, we then go through an overflow process, and that overflow process may end up putting that calc record into the new pages, although it still will be associated with the original page that it would normally target to in the original within the original page structure. As you may imagine, that's going to end up doing more I/O to get those individual records when they've been overflowed to this extended portion of the area. So this is another reason why you're going to want to do an unload reload or a reorg of these areas prior, sometime after doing the extend space to make the database a more efficient structure. Your VIA records are also, if they can't fit on their target pages, they are the ones that will overflow into these extended pages. So an area with extended space does have the potential to perform less efficiently than a completely unloaded and reloaded database. So some examples, or an example of doing the extend space. Here we have original area. It maps to one file, the EMP-demo region. We specify primary space of 500 pages. The maximum space must also, to be able to do an extend space, must have more pages than the primary space. Now, if you have not specified that, or maybe you came through and you said maximum space is 500 pages, when you originally defined this area, that's not a problem. You can just go through and alter the area's definition and change the maximum space to indicate a larger number of pages. So we're mapping that entire area into a file called EMP-file1. This is a 500-page area, and we said map it from block 1 through 500 blocks. So that's going to use page range 85,001 through 855,000. So to do the extend space, what I'm going to do, I will have to create within that segment definition another file, EMP-file2, and then on the area statement, I'll do an alter area for that area, and I'll say extend space 500 pages. And then tell IDMS to map those pages into EMP file from 1 through 500. You still, by default, it's going to still recognize the fact that the first 500 pages are mapped to EMP file 1. What you're doing with this statement is causing IDMS to say, okay, here's another file, and how do I map this extra 500 pages to that? So the first 500 pages continue to map to EMP file 1, but now pages 85,501 through 86,000 map to EMP file 2. So the steps for doing an extend space: we will vary the area from the CV and back up the area. Once again, we don't want anybody updating the database at the point in time that we're doing this particular procedure. You want to save the original DMCL load module as a backup. You want to make sure if something happens, let's say you're doing this in the middle of the night, and then to make matters even worse, you come back the next day and somebody says, you know, some of the batch processing that was done at noon of the previous day was bad. So now I've got to recover the database. Well, you want to make sure that you still have that DMCL load module available with the original definition of the area so that you can perform that recovery. So here is an important situation where you want to make sure that you retain that original DMCL load module. You will modify the affected segment by modifying the target area and adding the new file. So again, we're talking about the segment definition within your dictionary. You'll generate, punch, and link all the DMCLs that contain that modified segment. Allocate the new file, and here you must run the format utility against that specific file. If we have a CV that's been up during that period of time, we can execute the DCMT vary DMCL new copy or recycle the CV. Must do that to any CV that is currently using that area. Vary the areas back online, and you're ready to go. So we really don't even do any manipulation of the database files or the original database files during this process. We're just changing the definition so that IDMS will then use these additional pages for overflow processing. So these were our two short-term solutions to getting past a shortage of space within the database. But again, remember, all those things that we see in this first bullet here, those were things that were not fixed, were not improved upon by doing the expand page or the extend space procedures. So when you have more time available to you, you want to take a look at the longer-term solutions. I mean, maybe this is something that, you know, the next weekend or coming holiday weekend, maybe something over Thanksgiving, or however you would be able to fit this into your schedule. You want to take a look at some of these longer running utilities, but they provide long-term solutions. They will consolidate via clusters so that if we have long overflow change, those records are brought back, and we try to minimize the overflow that we're going to have. Fragmentation, variable length fragmentation. We can get rid of these variable length fragments doing the unload, reload, or a reorg. During the process of the unload, reload, reorging of the database, we rebuild all of the indexes that are involved with the areas being processed. So you end up starting with efficient index structures from the beginning instead of living with the questionable performance-wise structures that you had. And certainly if there are any relocated records in the areas being processed, we get rid of those relocated records. Now, this type of operation does require that the entire database be unloaded and reloaded. So the way you go about doing that is either using the unload and reload utility statements or using the relatively new, like it's hard to say that it's new because it was introduced right back about release 16, but the relatively new utility called reorg. So the first thing that we want to look at is unloading and reloading the database using unload and reload. Now, our diagram is a little bit different here than the ones that we've looked at before because I really here want to give you the overall impression of how the structure of the utility is actually used, and there are a couple of utilities that you are going to be using during this process. I should say that all of these statements, all of these utilities are utility statements, and they all run under the control of IDMS BCF. And with the exception of the cleanup, they all, the unload, reload, and format, they're all mostly considered local utilities. Now, one of the things to consider with an unloading, reloading of the database is you can't have logically deleted records. So the first step that you're going to want to do is run the cleanup utility if you have logically deleted records. And remember, we can determine logically deleted records by the use of the print space utility or dban. In this case, I'd probably run print space because it runs a lot quicker. Once I've cleaned up any logically deleted records, I then go on with the unload. All of these utilities, they all take the input parameters in through the DD statement sysipt, and they all produce output listings that go to syslist. Unload, as the name implies, goes through and reads the database, strips off the records for the specified areas, and writes them to intermediate files. Unload is really a single step that processes the entire database. Those intermediate data files are then read into the reload utility. So unload used the old DB as just retrieval. While you're doing the unload, you don't want another copy of IDMS updating the database, but there is nothing wrong with running retrieval access against that database. So you could conceivably, during the unload process, still have that area available to your CV for retrieval-only processing. The reload is going to require that it has control of all of the areas that are involved here, because it's actually going to be updating the database. So it's going to end up writing the new data into that database, and in some cases, some of the old database areas might be affected because of cross-area pointers. So they have got to be taken away from any other update or even retrieval processing during the reload process. Reload is actually a number of different steps that perform different information. For example, one step lays down the new data. Another step is going to rebuild indexes. Another step manipulates the pointer positions and rebuilds those, and finally goes through and updates those pointer positions. So reload can be run as a single job step, or it can be run as multiple jobs or multiple steps within the structure, whichever you feel more comfortable with. Before you actually go through and you run the reload, you're going to have to go through and format any new files that are involved with the structure, or if you are just unloading and reloading the same physical file, before you do the reload, you're going to want to do a format against those areas / files. Now, the things that are available to us in terms of enlarging the database are the fact we can change the page size, we can change the page ranges for the records, and we can change the maximum number of records per page. We're going to see in subsequent sessions that there are other things that can be accomplished when you do the unload-reload utility in terms of modifying some of the structure of the database. But in this particular case, our focus right now is just in enlarging the database. So these are the three things that are available to you or can be done to the database to enlarge that space. Again, change the page size, change the entire page range of the record, or more pages in the area, and change the maximum records per page. I alluded to this slide as we were going on. The unload utility unloads the existing database, and it requires the old and new descriptions of the database. So you are going to need a new, in some cases it may be an old subschema and a new subschema, and it may be an old DMCL and a new DMCL. What it does is it goes through and it reads a record using the old definitions and then passes it down to a routine that looks at the new definitions, the new page ranges and anything else that may have been changed, and based on that information comes up with a target page for that record in the new database. So unload has got to be able to have access to the old definitions of the database and the new definitions. Okay. And as I pointed out here, if schema changes were made, you must an old and new subschema. If physical changes are made, you must have an old and a new DMCL available. Reload simply reloads information into the new database. So all it requires is a description of the new database. And actually the names of the subschema and DMCLs that it's going to use for the new database get passed to reload from one of those intermediate files that gets created by unload. And again, you would be using that same DMCL and subschema that you specified as the new DMCL for the unload. Unload cannot be used to change a structure of a record. So you can't increase the size of the record, you can't increase fields within that record, you can't reorganize the sequence of the data within a record. So all you're doing is taking an existing record off the old database and putting it to the new database. And if you're dealing with an SQL-defined database, only the page range and page size can be changed. So our operating considerations. The unload reload must run in local mode. Again, unload, while that unload is going on, you can have other copies of IDMS in a retrieval mode accessing that database. But once you get to the reload process, the reload has got to have exclusive control of all of the areas and files involved with your unload or with your reload operation. Database areas to be reloaded must be formatted and contain no data. The implication here is, or basically what this is saying, is you can't use the unload reload to add data onto an existing database area. It is designed to basically start with an empty database and take information from one database to another. So if all you're doing, let's say you may want to do an unload reload, but you're not going to change the page range or the page size. You just want to reorganize that data because maybe you've got a lot of relocated records or overflowed records or fragments for variable length records. So all you want to do is kind of improve that structure. What you would end up doing is you'd unload the area, and then that area that is the target, or those areas that are the target of your unload operation, they must be formatted so that they are empty areas when you start processing. You can process portions of a database which consists of one or more areas. So if I've got a database that's made up of 3 areas, Area A, Area B, Area C, and the problem that I have is Area B, that's the one that I have to enlarge, I don't have to actually do an unload of A and C. I can leave the data on those areas and only offload the information for Area B. Now, if there are pointers that cross between those areas, in other words, a record in Area A that has a chain set to a record in Area B, Area A is still going to have to be available to the unload reload process, and it will get updated with the new DB key information when we reload the database. But you don't have to go through the overhead of actually reading those areas to extract all of the data from those areas. You would only have to do it for Area B. So we're going to now get into the steps for doing an unload reload. And if the physical characteristics of an area are changed, the following should be done prior to the unload reload. And here I want to create a reload segment, in other words, a new segment definition where the new page size, page range, or maximum records per page are defined. I'll create a new DMCL using that new segment, and I'll want to link that into a given library. And then allocate any new data sets with the appropriate characteristics. At this point in time, you could also do the format. You've got the DMCL, you've got the files allocated. You could format those new areas and files at this point in time. Make any of the areas involved in the procedure unavailable to any CV in update mode. Something we've talked about all the time in this next bullet. Again, another one, back up the original database. so that if I have to go back for some reason, whether the unload reload is not successful, or if I've got some recovery that has to go back prior to the unload reload, I want to go through and have a backup available. Remove any logically deleted records by running the cleanup utility. Again, I recommend using the print space utility to determine if there are any logically deleted records in that database area. Then you'll unload the existing areas using the unload utility, specifying the original DMCL in the job steps sys IDMS file. The new DMCL gets specified in the parameter statement, the unload parameter statement. So when unload executes and it starts up its individual run unit to access the database, it will go to sys IDMS to find the old DMCL to point it to the old database. Non-SQL databases require that you specify a subschema. However, SQL areas do not require the specification of a subschema. The components and control blocks that are used within the subschema, reside within the subschema, are actually generated within the SQL environment at runtime. So I've gone through, I've unloaded my database. I now want to initialize database areas where the data was physically unloaded and any new files by running the format utility. The thing here to remember, I gave you an example where I said I had 3 areas, A, B, and C, and A had pointers into B. But what I was processing was B. What I want to format, if I'm just keeping those areas, reusing the same files, is I would format the area B components. I would not format A or C. If you go through and you format area A as well, you're going to get all kinds of errors during the reload, basically saying it can't find records. So you only have to format those areas and their files for those areas that were specifically specified to be unloaded as part of the unload utility utility statements. And one point here, if you're accessing the catalog load area, DDL cat load, you also want to do an install stat utility. Should be done prior to actually starting the reload. You then execute the reload utility, and at the completion of that, back up the database. Back up your new database. Now, one of the things that I think is very important, and we'll see this in a number of our other utilities, verify the success of the unload reload. So it's not just a matter of saying, hey, it finished with condition code 0, the world is great. You want to go through and make sure that everything is still looking good, and we'll talk about that process in just a moment. After I've validated the database, I'll want to regenerate, punch, and link all of my DMCLs with the new segment definitions. And once I've done that, I can cycle my CVs. I could do a very new copy of the DMCL, however you want to bring those new DMCLs in, and then make the areas available to the appropriate CVs. Now, verifying the database. I want to take a second to talk about this. Certainly, you want to make sure that you've got all the same number of records. So we talk here about IDMS DBAN. You could also use print space. So I would recommend minimally doing a print space before. You should have been doing that to see if there's logically deleted records. But more or less keep that information or those reports available, because remember we saw on those listings, it indicated the various types of records in each area and the number of records that were available in each one of those areas. So keep that information and then run your print space or your DBAN afterwards and compare those numbers, making sure that the numbers are the same. You know, that there might not have been some type of setup problem. And then you also want to actually exercise that particular portion of the database. There's a couple things that we provide as utilities that you could use for that. They're listed down here below. There's online query, which allows you to specify the subschema and then walk the database. You could use culprit to do reports or IDMS DML online to access the database. But what I also recommend that you do within the confines of this time frame is if you have any types of application reports that probably just retrieval-only types of processes, run them to make sure that the data, the logical integrity of the data is still there. So it's not a bad idea to, maybe take some of these applications, run them before and then run them afterwards, and they should end up coming out with the same information because you're taking the old information and putting back the new information. So it should be the same information. So that's a step that I strongly recommend that you take into account. Okay, now we do have time constraints within this particular presentation, and so what we're going to be doing throughout the remainder of these webcasts is we will basically talk to our time limits, and then the next session, next Friday, we'll come back to the Enlarging the Database, and we'll pick up looking at the reorg. The discussion of reorg is going to take more time than we actually have available to us today. So what I want to do is cut it at this point, and like I said, next week we'll start with the reorg. And today, I'll turn it back over to Len, and we can deal with any questions and spend the rest of the time with any questions that you may have.
Great. Thanks very much, Dick. Appreciate it. Great job as always. So for those of you who are on the phone line, if you have a question, please feel free to unmute your line by hitting #6. That will unmute your line, and you can ask your question that way. I don't see any questions in the Q&A box at the moment, but now is the time. So if you have something you'd like to ask, please feel free to go ahead and do that. We'll give everyone a minute to type and or unmute their line. All right. It doesn't look like we have any questions this week, so we'll go ahead and wrap up. Dick, thank you very much. And for those of you who joined us today, we really appreciate you taking the time out of your busy Friday to join us and do this. As you know, we're going to be doing this over the next several Fridays, so hopefully we'll see you next week. Have a great weekend, everybody.